In this video, we've got a couple problems that we're going to do. And in the first one, we need to solve this equation for x. And you'll see that we have a square root over here on the left side, square root on the left or on the right side, and we have to undo those. So if we have the square root, to undo that, we actually square it. Because say if we had, I'll do this over on the right side, if we had 2x minus 15, which is what we do have, rewriting this in exponential form, we're going to get 2x minus 15 to the 1/2 power, because there's an invisible 2 here that we would technically, well, there's a 2 that would technically swing around here and make it the denominator of this invisible exponent of 1 right there. So this is what that equals over here. And then to undo that 1/2, we'd raise it to the second power. So then you'd have 2x minus 15 to the 2/2 power, and then that would eventually just be 1. So we'd get 2x minus 15. So that justifies squaring the right side to undo that radical, as well as squaring the left side to undo that radical. So we're left with x over 8 equals 2x minus 15. And you could do this like the same type of thing if you were taking the cube root of both the left side and the right side. So now let's solve this. We want to get rid of this 8 in the denominator, so let's multiply the left side by 8, and then let's multiply the right side by 8 as well. Okay, there we go. So these cancel out. 8 over 8 is just 1, so I'm left with x on the left side, and then we need to distribute that 8 with both of these terms. So 8 times 2x will be 16x, and then 8 times negative 15 will be negative 120. Now we need to get the x's on one side, so subtract 16x from both sides. It means we're left with a negative 15x equaling negative 120, and then we want to divide both sides by that negative 15. So then I'm left with x equaling a positive 8. And then again, we have to check this. So if we plug in 8 right here, 8 divided by 8 is 1. So we're taking the square root of 1, which is just going to be 1. And then if we plug in an 8 here, 8 times 2 is going to be 16. 16 minus 15 is just 1. And we're taking the square root of 1, so that's going to be 1 equals 1. So this checks out, and that's your final answer. Now remember, in the last equation, well, here we've got a new equation. Now we've got a new equation, but the difference between this one and the last one is that we're taking the cube root of both sides. So to undo the cube root, we could cube both, whoops, let me do this in red. We want to cube the left side, and then also cube the right side. And if I was going to do this over here, I'll show you why we can do that. 5x squared plus 4. If we were going to write this, well, the cube root of this, and we're switching it into exponential form, remember that this part under the radical is raised to the first power. And if we swing around that index and make it the denominator of this exponent, we've got 5x squared plus 4, and that's going to be then raised to the 1/3 power. And to cancel out that 1/3 power, we cube it, because we raise a power to another power, or when we raise a power to another power, we multiply. So we're going to get 5x squared plus 4 to the 3/3, which is just going to be 1, so we'd write this as is. So again, up here, because we can do that over here, we could just eliminate the radicals, and I'll have a 6x squared on the left side, well, 6x squared minus 60 on the left side, and then a 5x squared plus 4. And we just got to solve this like a regular equation. So we want to get the x's on one side, so let's subtract 5x squared from over here, which means we subtract 5x squared from that side. We're going to be left with just an x squared minus 60 equals 4. And then if you'll see, it's an x squared, and I'm thinking maybe we could do the difference of two squares here. So let's go ahead and subtract this 4 from both sides. So then I have an x squared, and that's going to be a minus 64 equals 0, because negative 60 minus 4 is negative 64. Now the difference to squares here will be x minus 8 and then x plus 8, which equals 0. You could set both of these parts equal to 0. It's going to be a plus, that's an x. So then x will have to be 8, and then also x will be negative 8. And going back to the difference of two squares here, if we have a perfect square in the front and then a perfect square in the back, which we do, and then they're separated by a subtraction sign, we could actually like take the square root of this first term and the second term, which is going to be an x and an 8, and then we separate it by a subtraction sign and then by an addition sign. So we do x minus 8 and then x plus 8. So these are our two answers. We want to check them just to make sure they work. If we plug in an 8 here, we have 8 squared, which is going to be 64, and then times 6, that's going to be 384, and then we're subtracting 60 from 384, and that's going to be leaving us with a 324, but we're taking the cube root of that. And then over here we have x squared, so we do 8 squared, which is 64, and then 64 times the 5, which will be 320, and then 320 plus 4 is going to be that should be 324. And we're doing the cube root of that, so that's going to be the same. Now we'd also plug in negative 8 for this, but we're going to get the same answers because negative 8 squared is going to be 64, and then we do the times 6 and then minus 60, and then a negative 8 over here is going to be a positive 64 again, so we're going to come up with the same situation here. So both of these answers work for this problem, and that's going to be your final answer.